In the previous video, we learned what refraction of light is. Refraction of light is a transmission of light through an object in which the light which is incident obliquely bends at the boundary of the two media. We also said that the bending of light in the medium is caused by the change in its speed. When light is traveling from an optically rarer medium to an optically denser medium, its speed decreases and it bends towards the normal. When the light is traveling from an optically denser medium to an optically rarer medium, its speed increases and it bends away from the normal. In the figure, the case above is from optically rarer to denser, and the case below is optically denser to rarer. But how does the change in speed result in the change of direction of light? I did mention in my previous video that we will understand this with the help of an analogy. For the next few minutes, just forget everything I told you about anything related to light and just concentrate on what I'm about to show you. Here's a shopping cart which has rotating wheels. Say I want to move this shopping cart from the road to the grass. Obviously, I will push it or apply a force on it. Assume that I will apply a constant force throughout its journey. Let us see what happens when I start to move from concrete road to the grass. What did you notice? As the wheels of the cart entered the grass surface, their speed reduced. The cart travelled at a much lower speed on grass than on the concrete road. And the reason for slower speed is rather obvious. The grass offers more resistance to the motion of the cart than the concrete road. Here, we can consider the concrete road and grass as two different media through which the cart is moving. Note that the direction of the cart is same in both the media. We can think about light in the same way. Something similar happens when the light is travelling perpendicular from an optically rarer to an optically denser medium. The optically denser medium offers resistance to the flow of light and hence its speed reduces. However, its direction does not change. Let's get back to our cart example. What will happen if the cart enters the grassy surface at an angle? Let us see that. This is how it would look. Now let's take the cart back to the original position on the road, and we will look at the movement very slowly. As the cart approaches the grass surface at an angle, its right wheel will enter first, and as it enters here, it will slow down. At that time, the adjacent wheel is still on the concrete road and is hence moving with the same original speed. So the wheel on the grass surface will move slower than the other wheels for some time. But let's focus on the two front wheels. Both the wheels are moving with different speeds. As the force applied is constant, what this will do is slightly turn the cart towards the right. The cart will change its direction and continue moving in that direction afterwards. So the direction changed. Now let me draw a normal to the surface now. We can see that the cart has taken a turn towards the normal. If the surface wouldn't have changed, the cart would have continued to move in this direction. But because the surface changed, the direction of movement of the cart also changed. Why am I telling you all this? It's because one can think of bending of light in the same way. When light is obliquely incident on the surface of an optically denser medium, its speed decreases and it bends towards the normal. Part of the beam that enters optical medium first slows down, making the entire beam to change the direction towards the normal. Now let me ask you a question. How will the direction of light change when it enters an optically denser medium to an optically rarer medium? Will it move towards or away from the normal? To answer this question, let's switch back to the cart example. This time, the cart is here on the grass and it's being pushed towards the concrete patch. What will happen here? This is how the direction of the movement of the cart will change. Why? Let's see the animation slowly. As the cart begins its movement, the right wheel will reach the boundary first, and after entering the concrete patch, its speed will change. Will it increase or decrease? It will increase. It's because the friction is lesser on the concrete road. So now this wheel will move with greater speed, but its adjacent companion is still on grass moving at a slower speed. So the change in their relative speeds will turn the cart towards this direction. If I draw a normal, you can clearly see that it's moving away from the normal in this case. If the surfaces were the same, it would have moved in this direction, but as they are different, the direction as well as the speed of the cart changes. We can apply the same analogy for the light entering from an optically denser medium to an optically rarer medium. Light can propagate more easily in an optically rarer medium than in an optically denser medium. In such a case, its direction of propagation will be away from the normal in the refractive medium. One last question to which you will definitely know the answer to. What if the cart is entering the concrete like this? Perpendicular to the surface? Yes, its speed will increase, but its direction will not change. So if the light is entering an optically rarer medium in a perpendicular manner, then its speed will increase, but its direction will not change. In the next video, we will talk about a few examples of refraction.